Recording in progress.
Okay, just the structure that you see right now in the whiteboard, the first example, if you see, it has 4 carbons. So if it was an alkane, which is this is the case, this is an alkane because it doesn't have double bonds or triple bonds neither. So it's a 4 carbon parent chain. That means that this is butane. Simple as that. Okay, 4 carbons indicates that it is butane. But in alkenes, we're going to have double bonds. Now, how do you identify a double bond? Take a look to this example. If I add one extra bond, like you see right there, you notice then that there is a double bond, okay? There is a double bond. So what happens? These double bonds indicates that it's not an alkane, it is an alkene because alkenes have the characteristic to have double bonds. Now, one thing that you must consider is that in alkenes, the first step, as usual, is going to be to identify the parent chain. But in this case, the parent chain for alkenes, they must include the double bond. If the parent chain that you do, imagine that you have a 9 carbon parent chain with no double bonds, okay? And then you have a 6 carbon parent chain with a double bond. Imagine that you have this situation. Now, the parent chain that you have to include is the one that includes the double bond. In this case, it's not about how many carbons you find in the parent chain, but to include the double bonds in the parent chain. That's the most important part. So for this example, for this particular example right here, the parent chain is going to be this one, okay? Including the double bond. Now, then it says, number the carbons from the same side where you have the double bond. So here you have to see the structure, and I'm going to divide the structure in 2 parts. I'm going to locate the structure in the middle, and I will see where the double bond is. Is it in the right or in the left? Where is the double bond located?
Left.
In the left. Because it is located in the left, that means that you will start numbering the carbons from left to right, okay? So the carbons are going to be listed as this is going to be the first carbon, second, third, and fourth carbon. Because the double bond is located in the left, you will start numbering from left to right. So now, so far, so good, but we haven't finished. We need to name this structure. To name this structure, we need to see where the double bond is located. As you notice, the double bond is located between carbon 1 and carbon 2, okay? So the double bond, it is between 1 and 2. So when this occurs, you have to choose the least number to indicate the position of the carbon. So in this case, you are going to choose number 1 as the main position of the double bond. So the name of this structure is going to be, in the position 1, you have the double bond. So it is not butane anymore because it has a double bond. So it's going to be butene because it is an alkene because it has a double bond. Okay, double bonds are alkenes. And that will be the name 1-butene, period. That's simple as that. Now, as an introductory example, it's quite nice, but we need to keep working. So I'm going to do one more example. Take a look to this structure. Which is going to be the parent chain in here? Which is going to be the parent chain right here? You can draw it in the whiteboard if you want. Or not, okay? Yeah, that is correct. Thank you, Ashley. So the parent chain could be the one that Ashley just draw in the whiteboard, or can be this one. Both parent chains are correct, okay? The most important thing is to include the double bond. If that is accomplished, then the parent chain is okay. Juan, Janice, I don't see your cameras on. Okay, so I'm gonna leave the structure, the parent chain that Ashley drew, which is this one. Now, that is my parent chain. So I will divide my parent chain, okay, in half. So where is a double bond? In the right or in the left? Right or left? Right or left?
In the right.
Okay, it is in the right. And that's important because you will start numbering the carbons from right to left. Okay, so this is going to be my first carbon, second, third, fourth, fifth carbon. Now, just like we used to do with alkanes, everything that is attached to the parent chain, it is an alkyl. So this one right here is an alkyl because it has only one carbon, is methyl. Okay, so uh, now let's take a look to the position of the double bond. In what position is located the double bond? In the position 2 or in the position 3?
In two.
The double bond is between 2 and 3, and as I told you, you have to choose the least number. So it's gonna be in the position 2. So the parent chain of this particular example is going to be 2, and because it is a parent chain of 5 carbons, it's going to be 2 pentene, not pentane. Remember, pentene because they are alkenes. Okay, but we always have to name the alkyls. Now the alkyl methyl is located in the position 4, and the alkyls are written first. So here is the full name, then it's going to be 4-methyl 2-pentene, and this will be the final name for this structure. Remember, between 2 and 3, you're going to choose the least number. That's why the double bond is indicated in the position 2. That's why here we have 2-pentene. Do you have a doubt in the second example? Okay, so no doubts. There are no doubts. Okay, let's see another example. This is interesting. Okay, here I'm going to ask you something before I go into the exercise. Is this the parent chain?
No.
Exactly. It is not the parent chain because a condition is that the parent chain must contain the double bonds. So the parent chain for this example must include all the double bonds that are in the structure. So this has to be the parent chain. Now, where is the double bond located, in the right or in the left? That's a tricky question. In both, that's the answer. Thank you, Ashley. Yes, I mean the double bond is located in both sides, okay? And so we cannot say that the double bond is to the right or to the left. No, it is in both sides. So because it is in both sides, we need to do the two paths, the blue path and the red path, okay? So I'm going to name the carbons, to number the carbons, 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, and 6. Okay, now I have to take a look to the position of the double bond. So here is just to analyze the double bond. Okay, so right now, according to the blue arrangement, the double bond is located in what positions?
One and five.
In 1 and 5. Okay, so between 1 and 2 we're going to choose number 1, and between 5 and 6 we're going to choose the number 5. Okay, so the double bond in the blue arrangement is in the position 1, 5. Now in the red arrangement, where do I have located the double bonds? In the red arrangement, where is the double bond? Where are the double bonds? 1 and 5. Okay, between 1 and 2 you're going to choose 1. Between 5 and 6 you're going to choose 5. So the numbers are the same, 1 comma 5. So the double bonds, doesn't matter what path you choose, okay, because the double bonds are in the same position. But here in this I have an alkyl, methyl. So according to all these ideas that I've been sharing with you, what color is going to be better for methyl, red or blue? Red, that is correct. Thank you. Remember that we see the two numbers that indicate the position. Okay, we see the two numbers, but we're going to choose the least of them. Or you can write the two names and then choose the better name. So when you choose the blue arrangement, is going to be 4-methyl and then the parent chain. This parent chain is amazing. You're going to love it. Uh, but if you do the red path, it's going to be 3-methyl. So, according to the ideas that I've been telling you on how to name, then the red arrangement is better. So we're going to focus on the red arrangement. Okay, we have 3-methyl and the double bonds are located in the position 1, 5. So this is important that you pay attention to. Jennifer, Melvin, Sheila, Minor, turn the cameras on. So this is important because I have 2 double bonds. Okay, 1 double bond. You do nothing. Okay, when you have 2 double bonds, you need to include a die between prefix and suffix. If you have 3 double bonds, you have to include a trie between prefix and suffix. Between prefix and suffix. You're gonna see what that is, okay? Pretty soon. If you have 4 double bonds, which it could happen, okay? Then between prefix and suffix, you're gonna have a tetra. You're gonna see what that is, okay? Here, because I have 2 double bonds, I'm going to choose this one in particular. So the parent chain is not going to be hexene. Hexene is okay if you have only 1 double bond because you don't have to add anything to it. But because I have 2 double bonds, I need to put between prefix, this is the prefix, and in is the suffix. Okay? So between the prefix and suffix, what you're going to do is you're going to add a die between because you have 2 double bonds. So here is going to be a die. The way to name this is 3-methyl 1,5-hexa diene. Hexa diene. This die part represents that you have 2 double bonds or 2 bonds, okay? And this A is just for, I guess, just for phonics because it sounds better. So the name will be hexadiene. If you, by any chance, you had 3 double bonds, the name will be hexatriene. If you had 4 double bonds, then this name would be hexatetraene. Hexatetraene. So the name gets more complex. Minor, Melvin, cameras on, please. Shayla, I don't see you. Okay, so again I repeat, because we have 2 double bonds between prefix and suffix, you will put a die between them. That is very important. So keep this in mind. Since I already finished, this is going to be the final name. Tell me, do you have a doubt in this exercise? This is a little bit more complex. Okay. It is complex, but you understand. Okay. Do you have any concern about this exercise? Yeah, there could be more double bonds, but to be honest, the most that I have included so far is three double bonds because I add alkyls to it. So the structure needs to make sense. I don't do so very long structure. So in the case of five double bonds, would be like that. But mm, I don't think I will include five double bonds. That's my guess. I'm not going to do very complex structures for you. To be honest, I only have included the most, sorry, has been four double ones, and two has been the most common for me. But yes, in case that you need it, there is the list. Now I don't know how to call this. I'm gonna call them special adjustments. Just to name them. Now, um, we can have a structure like this or like this. The number four, example number four. Let's take a look to the example four. What is going to be the parent chain in this example? What is going to be the parent chain in this example? That is correct. That's correct. That is the parent chain. So I highlight the parent chain and voila. Now where is the double bond located? Right or left?
Right.
It is in the right side, okay? Because it is in the right, I will number the carbons from right to left. So this is going to be my first, second, third, fourth, fifth, and sixth carbon. This is going to be methyl. And how are we going to name this alkyl? How do you name it? It is a cyclo because it is a cyclic figure and it has five carbons. So how do you name this cyclo? How do you name this cyclo? Cyclopentyl, not cyclopentane, cyclopentyl. Remember that when it is attached to the parent chain is an alkyl, so you have to make an adjustment in the name. So this is cyclopentyl. Very good, Jennifer. So this is cyclopentyl. So where is located the double bond? Position 2 or 3?
2.
Okay, 2. That's important. So remember, the alkyls are listed alphabetically. Methyl begins with M and cyclopentyl, aquí lo puse con I, pero es con Y, sorry. Cyclopentyl begins with P. So methyl is listed first and then the cyclopentyl. So the name will be 4-methyl, 5-cyclopentyl, and then the parent chain. The double bond is located in the position 2 and it is a 6-carbon parent chain, so it's going to be hexene. And that is going to be the name for it. Even though it looked a little bit complex, it was easy in the end. Do you have a doubt about this exercise? Melvin, your camera on, please. Vanessa, too. Okay. Let's work with the last example for today. I have this one. And here is important that you guys pay attention. In cyclos, this is a cyclo as a parent chain because it has more carbons than the chain that is attached to it. So the parent chain is the cyclo itself. Okay, so how are we going to name it? It is a cyclo of 6 carbons, so it's gonna be cyclohex. But take a look. The double bond is located here. When you have a double bond, you have to start counting the carbons from the double bond. That means you can start from here, 1, 2, or like this, 1, 2. Okay? The double bond starts with number 1. So you can you can continue numbering the carbons, 3, 4, 5, and 6, or 1, 2, 3, 4, 5, 6. Now, attached to the parent chain, you are going to have you are going to have an alkyl of 2 carbons, which is called ethyl. So you're going to have 2 paths, red and blue. If you choose the red path, the name for this structure is going to be 6-ethyl. Okay, I need to say something before I continue. I forgot. It is written here. Here it says, attention. In cycloalkenes, if you only have one double bond, this is the case, we have only one double bond, it is assumed to be always located in the first position. ¿Por qué? Porque cuando usted enumera el double bond siempre comienza con 1, ¿ok? 1, 2 o 1, 2. It doesn't matter. So the position of the double bond, if you only have one double bond, is going to be in the position 1. Entonces, por esa razón, cuando lo nombramos, no necesitamos escribir 1 cyclohexene o 1 cyclooctene. No ocupamos indicar que el double bond está en la casilla 1. Eso ya se sabe. Okay, because when you start numbering the carbons, you start with the double bond. Entonces ya se sabe que comenzamos en la posición 1. Ahora, por ejemplo, si usted tiene aquí este que tiene 6 lados, it's going to be cyclohexene, ¿verdad? No podemos decir one cyclohexene porque ya se asume, ya se sabe que es 1, que está en la posición 1. Lo mismo en el cyclopentene. El double bond se enumera a partir del número 1, ¿ok? Entonces, one cyclopentene ya se sabe que por ser alkene va a tener el double bond en la posición 1, por lo que decir one cyclohexene sería incorrecto y decir cyclohexene sin indicar el 1 sería lo correcto. So the red arrangement here no sería 6-ethyl y luego el cyclo, que el cyclo sería de 6 carbons, sería entonces cyclohexene. Pero si lo hacemos in the blue position, sería entonces 3-ethyl cyclohexene. Y a partir de ahí tenemos que escoger el mejor. Obviously, it's going to be the red arrangement. The blue arrangement. Entonces, este sería el correcto because it has the least number.